This is our second video discussing the first case of law of sines. We'll do a couple more applications here. An engineer wishes to measure the distance across a river. He determines that angle C is 112.90 degrees, angle A is 31.10 degrees, and side B is 347.6 feet. We want to find the distance A. We'll round our answer to the nearest hundredth. We're looking to find side A. Great. We know angle A. But in order to use law of sines, we know that we have to have a known pair. And right now, we don't have a known pair. Our other known side is side B, so we need to figure out what angle B is. Since we were given angle A and angle C, we can figure out angle B because we know that the three have to add up to be 180 degrees. So the measure of our angle B is going to be 180 degrees minus 112.90 minus 31.10 to give us 36 degrees. Now that we have this known pair of B's, we can set up our proportion for the law of sines. Side A over sine of 31.10 is going to be equal to our side B, which is 347.6 over sine of angle B, which is 36. To solve for A, all we need to do is multiply both sides by sine of 31.10. And we get our side A to be 347.6 sine of 31.10 divided by sine of 36. And we'll just pop this right into our calculator. We get that side A, rounding to the nearest hundredth, will be equal to 305.46, and our unit is feet. In our next example, a woman in a hot air balloon is directly above a straight road 1.5 miles long that joins two villages. She finds that the town closer to her is at an angle of depression of 35 degrees, and the farther one is at an angle of depression of 31 degrees. How high above the ground is the balloon? We'll round our answer to the nearest hundredth. As always, we want to start with a good diagram. So we have this road that's 1.5 miles long, separating two villages. I'm going to call them A and B. And we've got a hot air balloon. It's closer to one town than the other. They tell us that the angle of depression, so if here's our straight sight line, our angle of depression to the closer town is 35 degrees. And our angle of depression to the farther away town is 31 degrees. And we want to find how high the balloon is above the ground. We're looking for this height here. Okay. And that straight line will create a right angle there. All right, so let's talk about these angles of depression. Now, this road is flat, and our sight line is flat. So here we have two parallel lines, And we can look at cutting it with this transversal. We know that alternate interior angles are congruent, so that makes this angle down here at village A 35 degrees. A similar thought now looking at this transversal going from the balloon to our village B. Again, alternate interior angles are congruent, so that's going to make this angle at village B 31 degrees. So for the moment, I'm going to get this height line out of here and look at this big triangle here. Now, since we know two of the angles in that triangle, we are able to find the third angle because they have to add up to be 180 degrees. So 180 degrees minus 35 minus 31 gives us an angle up here of 114 degrees. I now have a known pair with my 1.5 distance and my angle of 114. And I'm going to find one of the sides. It really doesn't matter which one we find, the distance from the balloon to A or the distance from the balloon to B. I'm going to find the distance from the balloon to A. So this will be our second known pair that we can write a proportion for. We'll have 1.5 over sine of 114 equal to side, I'm calling it B because we're across from village B, sine of 31. To solve for our side B, we'll simply multiply both sides by sine of 31. That makes our side B equal to 1.5 sine of 31 divided by sine of 114. We'll pop that into our calculator and get that our side B is equal to 0.845669042. Now, I'm not rounding this answer at all because I'm in the middle of the problem and I don't want to round until I get to the very end, so I'm going to keep every decimal place that my calculator gave me. All right, so now we have this side B. And I'm going to bring my height line back into the conversation, because this is what we're trying to find. This creates a right angle, so we have a right triangle right here where we know one of the angles and one of the sides, and we're looking to find the other side. We can use SOHCAHTOA to find that height. From our 35-degree angle, the height is opposite and the hypotenuse is known. So we're going to use sine here. I think I'm going to draw a breakout triangle. So we'll have sine of 35 degrees equals our opposite side over our hypotenuse. And then to solve for h, we simply need to multiply both sides by that 0.845669042. h will then be equal to 0.84569042 times sine of 35. And then we'll just pop that right into our calculator, and then this answer will round to the nearest hundredth. We get that the height of the balloon over the road is going to be 0.49, and our unit is miles.